Hi, everyone, and thank you for joining us today. My name is Melton, and I'm going to be your moderator for today's presentation, Johns Manville's high-temperature industrial insulation products. Before we get started, I do want to talk a little bit about this presentation. It's a little different than our typical ones, where we are just going to be talking strictly about the JM high-temperature industrial insulation product portfolio. This is a great opportunity for you to learn about the product that JM has to offer and the materials that are available out there for industry uses. So with that, I want to go over a few logistics before we get started. First and foremost, submitting questions. We will take all your questions, or as many as we can, at the end of the presentation. So you should see a Q&A to the right side of your screen. Now, if you don't see a Q&A, at the very bottom right corner, there's a small ellipsis. That's those three dots. If you click on those, it'll open up a little dialog box that allows you to click Q&A. That'll open up the panel that will allow you to submit questions to us. So we will be able to take those questions there at the end of the presentation. Also, this webinar is for educational purposes only and shouldn't be used as a substitute for any professional engineering design, consultation, or documentation that's required by building codes, contracts, or applicable laws. So if you have any questions about this after the webinar, you can refer to our specific application guidelines and instructions, and those are located in the product sections of our website, or you can reach out to us directly on our website. Also, we will conclude today's webinar with a survey. Now, this is your opportunity to provide us with feedback on how we've done today. You know, we try to make these as educational and helpful as possible, but that's not just a one-way street. That your feedback is a crucial component to allowing us to do that. And it's also part of how we deliver the JM experience to you. And the JM experience is down there in the bottom left corner of your screen is people, passion, perform, and protect. And those are the four pillars that JM stands on, the four values that we adhere to. And part of the survey, when responding to the survey, is part of how we deliver the JM experience to you. Also, we're frequently asked whether or not we send out these presentations upon their conclusion, and while we won't send out a copy of the presentation itself, we will post a recording of it online. That allows you to watch it at your leisure, share it with your colleagues, and ensures that you can have the presentation within its full context. Now, when that's complete, we will send an email to you so that you can access it live on our website. So with that, I'm going to take us to some introductions. Joining me today are Jim Young and Scott Sinclair. And Jim, if you could kick us off with an introduction, that would be great.
My name is Jim Young. I'm the cold mechanical insulation and metal jacketing specialist engineer for Johns Manville. I have an engineering degree from Case Western Reserve University way too many years ago, and I've worked in the mechanical insulation industry for about 23 years doing my current or similar roles.
Good morning and good afternoon, everyone. I'm Scott Sinclair. I am the National Specification Manager for Johns Manville Industrial. I've been with JM in this role for about 1.5 years. I've been working in the industrial insulation field for about 17 years, and I have an electrical engineering degree, so I am an engineer by background. And with that, we'll go ahead and kick things off and get started. I've got a lot of information we're going to try to cover today, so I'm going to go through it quite quickly. If you do have any questions, as Kim mentioned, please submit them through the Q&A session, and we'll try to get to them at the end of the presentation. We'll start off taking a look at some design considerations before we talk about any of the products that are in our hot insulation portfolio. It's very important because there are a lot of different materials available to fulfill the needs of a hot insulation system, that you take a look at what the most important design considerations are for the application that you're looking to design an insulation system for. And those design considerations can include things like the thermal performance of the insulation material, whether or not corrosion under insulation is a significant concern that you need to address, whether or not the material needs to have a fairly good compressive strength so that it reduces the risk of mechanical damage during or after installation. Does the application require any type of fire protection? Is moisture resistance important? This can tie in quite well with the whole CUI issue as well. How important is material profile? Do you have some limitations on spacing, and therefore you need to design a system that is the thinnest possible profile? Is there a lot of vibration in the application, and therefore you need a material that has the best resistance to potential vibration damage? And could weight be an important factor? We do have an insulation selection matrix, as you see in the image on the right-hand portion of the slide. that weighs each of our primary insulation products and their performance in each of some of these key design consideration areas. Might be a very useful tool for you, and that can be downloaded from our website as well, or if you have trouble finding it, please feel free to reach out to us and we can email a copy to you. Touch on a couple of those key design considerations before we talk about the products themselves. A very important consideration these days is corrosion under insulation and the potential for the insulation material itself to possibly contribute to any type of corrosive condition within the insulation system. One of the key measures for looking at the corrosive potential of an insulation material is the test procedure defined by an ASTM standard, and that is ASTM C1617. Defines a method for doing that, which I don't have time to go into detail today. The data presented in this slide shows what's called a mass loss corrosion rate ratio for different materials that have been tested to this procedure, basically looking at the mass loss corrosion rate as for the individual insulation product as a ratio to that of DI water. DI water is typically considered to be quite inert and not contribute to corrosion. So you're basically looking at the ratio of the material to that of the DI water. And you can see from this data that some Silica Aerogel products represented by the orange and gray bars have fairly significant corrosion rates as compared to that of DI water. Both of these products, as signified by the little water droplet, are hydrophobic products. The red or maroon colored bar toward the middle of the chart is a water-resistant, water-repellent mineral wool product, again having a significantly higher corrosion rate than that of DI water. The blue bar, again a hydrophobic product, that is Johns Manville's Insulin HT, which is our microporous thin blanket. That product has about the same corrosion rate as DI water. And then our last two products, represented by the purple and green bars, are Thermo 1200 calcium silicate and our WR 1200 perlite, both of which contain our XOX corrosion inhibitor, demonstrate the best performance of any of the materials tested, having a corrosion rate about half of that of DI water, therefore demonstrating that the XOX corrosion inhibitor is actually providing enhanced CUI performance. So if you are very concerned about corrosion under insulation, referencing this data and looking at the performance of materials tested to this procedure could be an important thing for you to do. Another very important aspect of material performance is taking a look at the insulation temperature range. What are the ranges of temperatures for the piping or equipment that you're going to be insulating, and making sure that you pick a material that is rated to cover that range of applications that you're working with. You see most of the typical products used in industrial insulation systems represented in this chart, and clearly see how each product has its own range over which it could typically be used and not be at risk of degradation because it's being used at temperatures beyond what it is rated for. So now we will move forward and start taking a look at the products within the Johns Manville high temperature portfolio. Do want to point out that we probably do have the broadest and most expansive range of products of any of the suppliers of insulation products for the industrial applications. We have a complete line of mineral wool products, our Expanded Perlite family, the calcium silicate product line, microporous thin blanket, the Insulin HT that I mentioned earlier, as well as a line of accessory products that go along with those, adhesives and coating materials, so that you can have a complete and properly installed system. We'll start off taking a look at our calcium silicate. That is our Thermo 1200 product. This is available in pipe sections as well as block and V-groove, beveled edge, and curved segment formats depending on what the application is in particular, if it's a pipe or piece of equipment or possibly a tank or a vessel. So it is available in a wide array of formats. Some of the primary benefits of calcium silicate, one of the most significant is the XOX corrosion inhibiting package that I mentioned earlier. If you're interested in learning more about that, please let us know, and we can schedule an additional discussion to go into that in much more detail with you. Our calcium silicate product is water resistant, and I'll touch a little bit more on that in a couple of slides. Of our hot industrial product line, it does have the best compressive strength rating. So it is going to be the insulation material that's going to give you the best protection against potential mechanical damage during and after installation. And it does have a consistent thermal performance. And what we mean by consistent performance is that the thermal conductivity that you get the day the material is installed will be the same thermal conductivity performance that you will see 10, 20 years later. There is no change in the performance of the material over time and different operating temperature conditions as long as it's used within its rated range. Some additional highlights of the Thermo 1200 calcium silicate product line. You can see on the right-hand portion of the slide some of the different formats that the product is available in. Our Thermo 1200 is rated for a maximum operating or application use temperature of 1200 degrees Fahrenheit, 650 degrees centigrade. I mentioned the compressive strength. It is rated for a minimum of 100 psi. So it is going to give you excellent protection against potential mechanical damage from people walking on the pipes or dropping tools or equipment on it. As I mentioned, it is a water-resistant product. It does contain the XOX corrosion inhibitor, so it contains many of the features to help protect it against some of the risks that it might see during its lifetime. Has a rated density, nominal density of about 14 pounds per cubic foot, a minimum of 14 pounds per cubic foot, and it is good for pretty much any of your applications, piping equipment, tanks, vessels, and things of that nature. So very well suited for pretty much any of your applications that you would encounter in an industrial setting. Touch a little bit more on the water resistant feature of the product. It is designed to absorb less than 15% of its weight in water over 20-minute exposure to what we consider a heavy rainstorm, and that is defined as approximately a 1 1/4 inch per hour rainfall. The primary focus of the water-resistant feature of our calcium silicate is to benefit the contractors during installation, buy them time in the event of a rainstorm that comes through while they're doing the installation and don't have the outer jacketing installed yet. You can see from the chart at the bottom, we did some testing comparing our current generation Thermo 1200 calcium silicate to some previous generation non-water resistant calcium silicate. And you can see with exposure to that 20-minute rainstorm, the Thermo 1200 absorbed about 7% of its weight in water, whereas the previous generation material was over 80%. When exposed to that rainfall for 1 hour, 60 minutes, the current product absorbed about 25%, or Thermo 1200 absorbed about 25% of its weight, whereas the previous generation material absorbed almost 3 times its weight in water. So definitely providing an additional benefit that can be very, very helpful during installation and provide some additional consideration for CUI protection during the life of the installation. This has been an integral part of our Thermo 1200 products since 2017. As I mentioned, it gives the contractors much more time to install the jacketing, not have to worry about the insulation material getting wet, absorbing water, and then having to be removed and replaced. So it can result in improved efficiency for the contractors during the construction and installation phase. Does have very high compressive strength, as we mentioned, minimum of 100 psi, and does contain the corrosion inhibitor. We often get asked, okay, what exactly is this XOX corrosion inhibitor package? and it is something that is part of the chemistry or formulation of the Thermo 1200 during the manufacturing process. It's a combination proprietary blend of silicates that are part of the chemistry of the material that provide on-demand protection in the event that water does get into the insulation system or the material gets exposed to water. It's been integral to the product since 2002, so it's been out there for quite a while. And it basically does two things in providing that protection. One, it provides a pH buffering. For a corrosion, you typically need an acidic environment, a low pH environment, and this package is going to provide buffering in the event that acidics do get into the insulation system from the outside environment, things like acid rain or other ways of that happening. And it also forms a protective physical coating on the surface of the metal. If that water does get in, it's like a passivation layer that will protect the metal against future exposure to corrosives. This package is dormant as long as the insulation remains dry and is only activated in the event that water does get into the insulation system and come in contact with the calcium silicate insulation material itself. And those corrosion protecting or inhibiting properties will be present for the life of the installation. We have several other products within our calcium silicate family in addition to the Thermo 1200 product line. We have an HP block product line that is a block-only format, no pipe sections or curved segments. We have a Super CalTemp Gold 1700. That's our high-temperature calcium silicate product rated for 1700 degree maximum use temperature. And then we have our Super Fire Temp products, including the Super Fire Temp L, that again is a block or board product. And again, if you're interested in more information on passive fire protection capability of our calcium silicate family, please let us know, and we can follow up with much more detail. Here is some of the information that is available on the performance that each of these products can provide. The performance is obviously very specific to the material being installed as per the configuration under which it was tested. So you do need to install the product and the thicknesses and layers that were tested, as well as the install method and the jacketing material and installation method as well. You can see with our HP block, we have fire ratings per UL 1709, which is the pool fire test, configurations that meet requirements for 30, 60, or 90-minute ratings. With the Thermo 1200, our thermal insulation product, we have a 60-minute rated configuration. With both the Super Fire Temp L and our Super CalTemp, we have 120-minute rated configurations. So again, if you would like more information, let us know, and we can share more detail with you. Closing up our discussion about calcium silicate, we do have a couple of questions that we often get asked that we can go ahead and address for you up front. Is the XOX corrosion inhibitor a coating? And the answer to that is no. It is actually part of the chemistry of the insulation material and integral to the material itself. Is all CalSil water resistant? Within the JM product family, both our Thermo 1200 and our HP block are water resistant. The Super CalTemp and the Super Fire Temp are not. And it is also important to know that not all other manufacturers or suppliers of calcium silicate product have a water resistant feature in their material either. So it's definitely something that if this is an important feature for you, that you would need to investigate. And does the XOX corrosion inhibitor burn off like hydrophobic treatments can? And the answer to that is no. This is not something that is organic in nature and is going to burn off based on any operating temperatures that the material might be exposed to. So with that, we will move on to the next product in our family, and that is our WR1200 Expanded Perlite. This product is also available in a couple different formats. The spool WR1200, it's in molded pipe sections as well as board block and V-groove. So again, applicable for pipe, equipment, tank, vessel type applications. Does also contain the XOX corrosion inhibitor package that we discussed with our calcium silicate line. It is a hydrophobic product, so it is going to be water resistant to a slightly better or higher degree than the Thermo 1200 calcium silicate would be. So it will absorb less water more slowly. Does have good compressive strength rating as well. And similar to the Thermo 1200, has consistent thermal performance. So your thermal conductivity day one is going to be the same on year 10, year 20. You're not going to see any degradation in thermal performance. Also rated to a maximum of 1200 degrees Fahrenheit. The compressive strength rating is 80 psi, so not quite as good as the calcium silicate, but still very good for areas at risk of mechanical impact and damage. As we just highlighted, it is hydrophobic and does contain the XOX corrosion inhibiting package. Has a density of 13 pounds per cubic foot, so very similar to that of the calcium silicate. And similar to the Thermo 1200, good for your pipe, tank, vessels, equipment applications. Very, very popular and used quite frequently in applications where stainless steel piping and equipment is used because the perlite product has a very good natural performance with regard to mitigating stress corrosion cracking on stainless steel. So that is one area where we see perlite being very popular. Facilities at or close to the coast where there is a significant exposure to the salt air environment, which would put stainless steel piping and equipment at risk. It would be a very common application or use for the perlite product. Comparing the spool 1200 perlite with our Thermo 1200 calcium silicate, both are water resistant, whereas the perlite is hydrophobic, so it's just a higher level of water resistance. Fairly similar in terms of their compressive strengths and densities. The Thermo 1200 calcium silicate does have a lower thermal conductivity across the entire temperature range than the perlite product does. So for the same thermal performance, you might find that the perlite requirement would be slightly thicker than that of the calcium silicate. And the perlite product does have a tendency to be more brittle than the calcium silicate. The calcium silicate would be more durable. So even though the perlite has a good compressive strength rating, it is a little bit more brittle in terms of potential damage during shipping or just during handling and installation if it is bumped against a hard surface. Some frequently asked questions for our perlite product line. Does hydrophobic mean better CUI mitigation? And while a water resistant or hydrophobic property in an insulation material can help toward decreasing the risk of corrosion under insulation, it is by no means a silver bullet solution for completely mitigating corrosion under insulation. So it would be a mechanism for to be considered or a feature to be considered in your overall CUI strategy, but it wouldn't be a single standalone solution. Is there any way you can mitigate breakage during transit? As I mentioned, the perlite product does have a tendency to be a bit more brittle and can be damaged during transportation and handling. We have fairly recently, late last year, made some changes in our packaging of the perlite product. Each individual pipe section of the perlite is wrapped in a fairly high gauge or thick poly shrink wrap and then packaged in the box. And that, based on our most recent experiences with shipping it packaged in that format, is showing a significant improvement in reducing the amount of damage during transportation. And does the perlite product have the XOX corrosion inhibitor package, and does it burn off in the perlite material? And the answer to that is yes, it has XOX, and no, Similar to our calcium silicate, it does not burn off. It is there for the life of the material. The next product that we'll overview quickly is our hydrophobic microporous blanket. That is our Insulin HT. This is a fumed silica blanket. This is a product that, of our hot insulation product line, has the best thermal conductivity performance of any of the products that we offer. So it is going to give the same thermal performance in a thinner profile, typically about half the thickness of the other products. So this would be an excellent product to consider when you have applications that are very space limited, pipes that might be too close together, or pipes that just don't have clearance to adjacent structural elements. It does naturally have a very low corrosive potential, as you saw from that very early CUI data that I reviewed. It's very similar to that of DI water, so even though it does not have the XOX corrosion inhibiting package, it has very good corrosive performance. Excellent for hybrid application systems, used in combination with mineral wool, calcium silicate, or perlite, to look at possibly mitigating some of the limitations that other products may have. It is also a hydrophobic insulation product, and a very important feature for the microporous thin blanket is that it also does have a very consistent thermal performance, so no change in thermal conductivity with exposure to elevated temperatures, as you might see with some other products. Again, rated for a maximum application temperature of 1200 degrees Fahrenheit, compressive strength of about 3.6 pounds per square inch or better. It is a hydrophobic product, but does not contain the XOX corrosion inhibitor. However, as I mentioned a moment ago, it does still have excellent CUI performance. Its core density is about 12 pounds per cubic foot. It's available in two formats. It is a blanket or roll product, available in 5 millimeter and 10 millimeter thick blankets. Does not exhibit thermal shift, and we'll touch on what thermal shift is in the next slide, I believe. And applications, this type of a product, the thin blanket type product, is best for areas, as I mentioned earlier, where you have space constraints, or in applications of large pipe or equipment, where it's going to be a whole lot easier to wrap a blanket around it than it might be to install beveled edge block or curved segments or something of that nature. Touching on thermal shift real quick, what is thermal shift? It's a permanent change in an insulation material's thermal conductivity when it gets exposed to higher temperatures. This can actually start at temperatures as low as 300 degrees Fahrenheit. It is a time temperature thing, so the higher the temperature, the longer it's exposed to those temperatures, the more shift you will see to a certain point. That degradation will reach a point at which it won't continue to degrade anymore. Based on all of the different products, insulation materials we have tested, Silica Aerogel seems to be the only product that exhibits this characteristic. That shift in thermal conductivity can be fairly significant, upwards of 15–20%. And the risks of thermal shift are that if the thickness of the material was calculated based on the pre-thermal shift thermal conductivity values, you could have less thermal performance than the system was originally designed for, which can mean that you now have a higher surface temperature than you originally calculated, or you have an increase in heat or heat loss or energy loss, and therefore the system isn't going to operate as efficiently as designed. These charts do a comparison of silica aerogel material as compared to Insulin and compared to each product's ASTM standard for thermal conductivity values. The chart on the left is for silica aerogel. You can see the line, the kind of gray in color, for the maximum thermal conductivity per the ASTM C1728 standard. The blue line is the thermal conductivity values measured for the first cycle, thermal cycle of the product, showing that even there the material doesn't always meet the maximum rated values per the standard. And then the second line, orange or red in color, is the second cycle thermal conductivity value, showing how the thermal conductivity increased quite significantly across the entire temperature range, whereas the chart on the right for Insulin shows that the first and second cycle lines are completely overlaid on top of each other, so absolutely no change in performance, and always below the maximum allowed value per the ASTM standard for microporous thin blanket. Where would you use Insulin? As I mentioned earlier, excellent for areas where you have space constraints or large pipes, vessels, tanks, where a blanket product would lend itself to improved installation efficiencies. Why would you use Insulin instead of a molded product? Again, looking at that installation trade-off is a primary focus there, as well as areas where you might need to look at a thinner insulation material because you don't have clearance, but you still need the same thermal performance. And how do you handle elbows? Again, we can go into much more detail about this later, but we do offer a complete line of prefabricated elbow segments layered for each of the layers within the system and designed for ease of installation in the field and eliminating the need for the complicated layout and cutting in the field. Last product line in our hot insulation family is our mineral wool product. So in addition to being an excellent product for thermal insulation applications, a very important feature of mineral wool is its acoustic performance. This is a very commonly used material for industrial applications where you're worried about noise reduction. And again, we can share much more information with you about that at another time. Let us know if you're interested. It is rated as a non-combustible material, as are the rest of our product family, has consistent thermal performance, very lightweight, and offers some significant benefits for job site storage as well as transportation that I'll touch on in a moment. Within the mineral wool product family, we actually have a fairly wide portfolio of product configurations as well. From our mandrel wound product, also known as molded pipe sections. These are all tested for water absorption for BSEN 13472 and ISO for water absorption and ISO 15665 for acoustics. It is a completely water resistant product line. And then 3 different formats of the V-grooved material, and this is basically a board format of mineral wool that has precision grooves cut in it such that when you curl it around the pipe, those grooves close completely and it actually looks and behaves exactly like a molded piece of mineral wool pipe insulation. The V-groove product's available in 3 formats, what we call preformed, so we pre-curl it for you and ship it either in a one piece or in a half shell set format. In field formed, where it does ship to you flat with adhesive in the grooves, and the installer would curl it around the pipe and during installation, or in what's known as precision cut, which is the same as field formed, but just does not have any adhesive in the grooves and again ships flat. For acoustics in an industrial application, the most widely adopted standard in the industrial sector is an international standard called ISO 15665. This standard defines 3 classes of acoustic performance systems, a Class A, Class B, and Class C. And then there is an additional Class D system that was developed by Shell Corporation. We do have configurations, as you can see from this chart and the pictures beneath it, that meet the requirements of each of these classes. And within each class, there are also sub-classifications for pipe sizes. So a size 1, 2, and 3, with size 1 being the smallest and 3 being the largest. An important thing to remember is that a Class 1 certified system does not necessarily meet the requirements of a Class 2 or Class 3. So if you do have larger pipe diameters, it is important to make sure that you are using systems that have been rated for the appropriate pipe size classification. All of our configurations are approved and certified to meet the requirements of the pipe size 3, So as you saw from the previous slide, we have an A3, B3, C3, and D3 certified configuration. And I believe we are the only ones who do have certified systems for that subclass 3 requirement. Within each of the configurations, all of the products that are needed, whether it's the mineral wool pipe insulation, the mass-loaded vinyl, or the aluminum or stainless steel jacket, JM does supply all of those products. So one of the benefits is that you can get all the materials needed for your acoustic system from one supplier. A couple benefits, additional benefits, looking at the V-Groove product, I mentioned shipping and storage benefits. You can see a comparison of how the molded pipe insulation material ships versus how the V-Groove product ships. So you can get a lot more material in the same amount of space with the V-Groove configuration, therefore occupying a whole lot less space in your warehouse or in the staging area on the job site. And from a shipping perspective, looking at the same configuration, shipping in molded pipe format versus V-Groove, you can get over twice as much material on a truck looking at the V-Groove configuration as you can the molded. So huge benefit there because you'll be paying a lot less in transportation costs. Trying to wrap up real quick on the products within the mineral wool portfolio. We do also have some board and bat products, also tested to BSEN 1609 for water absorption. We have an industrial board product as well as a flexible bat. And then we also have some wrap and blank products, our lamella tank wrap, our pipe and tank wrap, both of which are faced products, as well as a metal mesh blanket. So some highlights again, rated to 1200 degrees Fahrenheit, compressive strength of a little under 1 pound per square inch, does not contain the XOX corrosion inhibitor. The most common density is 8 pounds per cubic foot, though for some of the configurations we do offer other densities. In addition to the ISO 16665 classification and testing for acoustics, there's also a noise reduction coefficient or NRC rating for our mineral wool products that is an additional indicator of acoustic performance. So that would be something else you can look at in that area. And then touch real quickly on one potential concern with mineral wool products, and this is true of all mineral wool products. The adhesive binder that is used to hold the mineral wool fibers together during the manufacturing process is an organic binder. It does oxidize and burn out somewhere around 350 to 400 degrees Fahrenheit. The good news of that is that the thermal performance of the material doesn't change when binder burnout occurs, but you do need to be cognizant of the fact that this happens because when the binder has burned out, there is a reduction in compressive strength of the material, and you can run the risk of increased potential for damage if people are walking on the pipes or in high vibration environments with the fibers being shaken loose and settling to the bottom of the jacketing system. What's the best temperature range for mineral wool? That is going to be highly dependent on your application and whether or not you have something where you're worried about mechanical damage or potential vibration. As I said, it is rated to 1200 degrees Fahrenheit maximum, but you may want to use it for lower temperature applications if you do need to be concerned about binder burnout. Can the corrosion inhibiting package be added to mineral wool? And unfortunately, the answer at the moment is no. We do not have the ability to add that feature to our mineral wool at this time. And then closing up on our products, we do have a line of accessories to be used with our insulation products, protective coatings, adhesives and glues that go along with the calcium silicate and perlite products within the family. So with that, I know that was a kind of a speed test there. I will hand everything over to Mr. Young, and I will let him speak with you with regard to our metal jacketing and accessories products.
All right, well, thank you. This is Jim Young. I'll be presenting, as Scott said, the portion of this webinar on metal jacketing and accessories. All right, let's see. We'll move down here. JM has a wide range of metal jacketing products, as shown here, and I'll talk about most of these in more detail in the coming slides. There are a lot of complex aspects to how metal jacketing is installed on pipes, tanks, and equipment, but we're not going to be discussing installation today. If you have installation questions, contact JM and we would be happy to discuss this with you. We also have a full metal jacketing install guide for pipe on our website. The specific categories of metal jacketing products that I'll discuss today are our roll jacketing, sheet jacketing, and our two-piece pressed elbows. We also have a line of accessory products including banding, seals to secure the banding, screws and springs, but we're not going to get into the details of these today. We won't discuss the accessories. So if you have detailed questions of these, contact JM. I'm also not going to go into the details, but all of our metal jacketing meets the applicable ASTM requirements contained in the metal jacketing standards C1729 and C1767, as well as the applicable metal alloy standards such as B209 for aluminum. Before we get into a discussion of the metal jacketing, we need to first mention moisture barriers. A moisture barrier is a film or coating that's applied to the interior hidden surface of the metal jacketing, whose purpose is to reduce the likelihood of jacketing corrosion on this interior surface. The picture on the bottom right here shows a very bad case of this type of corrosion where it got so bad that the corrosion broke through the metal and is visible on the exterior surface. While this looks like it might have begun as corrosion on the exterior of the jacketing, it did not. It began on the interior surface. There are three types of moisture barriers: paint, polycraft, and polyfilm, and the performance of each are shown here for several key properties. We don't have time today to get into all the detailed performance of the various moisture barrier types. We've got literature and an entire presentation discussing the importance of moisture barriers on metal jacketing and the superior performance of polyfilm moisture barrier. If you'd like more information on this, contact JM. Suffice it to say for now, though, that corrosion science, lab testing, and real-world results all point out the importance of using a moisture barrier on the interior surface of the metal jacketing and how polyfilm is the superior choice amongst moisture barriers. It is important to understand that polyfilm is not a proprietary product. It is available from all metal jacketing manufacturers, and JM strongly recommends that all metal jacketing be specified to have a polyfilm moisture barrier on the interior surface wherever this is available. Metal roll jacketing from JM is available in various types, all with lengths of between 50 and 300 feet. We have aluminum with a bare exterior, which is our standard product, which has good corrosion resistance due to the nature of the aluminum. We have aluminum with a painted exterior, which has improved corrosion resistance and a different aesthetic appearance desirable in some applications. Lastly, we have two grades of stainless steel, type 304 and type 316, which provide superior and excellent corrosion resistance respectively. In addition, stainless steel jacketing is specified when the specifier wants the insulation system to provide an added resistance to fire. All of our roll jacketing is stocked in the standard 3-foot width, but other widths can be available. All our roll jacketing is available in smooth, stucco embossed, or 3/16 corrugated finish. The choice of finish is mostly based on aesthetics, although the smooth finish will reflect sunlight more, which is undesirable in some rare situations. The type of metal will influence the appearance and the emittance. Bare aluminum is quite shiny and has an emittance of 0.1. Painted aluminum can be different colors. It has an emittance of 0.5 to 0.8 depending on the type of paint. Stainless steel jacketing has a duller mill finish with an emittance of about 0.3. For insulation system design where the outer surface temperature is important, like personal protection and condensation control, a lower metal jacket emittance will usually require the use of greater insulation thickness. The next product we'll talk about is our acoustical metal jacket. This product is called Muffle Jacket. It's sold in rolls. It's a thicker 0.020-inch thick aluminum jacketing laminated to a 1-pound mass-loaded vinyl layer. This adds a lot of mass to the outside surface of the insulation system, which helps absorb, dampen, and block sounds, which reduces the noise emanating from insulated pipe tanks and equipment. Our next product is our cut and roll metal jacketing. Cut and roll comes in the same metal alloys, exterior surfaces, and finishes as our roll jacketing. This product line is really identical to our metal roll jacketing, except that it is pre-cut in our factory to fit around insulation of a specified size. The cut and roll includes a standard 2-inch overlap at the longitudinal joint, and a half-inch safety hem can be added if so specified. The next product line is our deep corrugated sheets. These are our standard metal jacketing, cut to length, and with a sine wave sort of pattern pressed into it. These are available in either aluminum or type 3 or 4 stainless. The exterior surface is unpainted, so it has the natural emittance of the metal alloy used, 0.1 for aluminum, 0.3 for stainless. The interior surface has a polyfilm moisture barrier. The typical stocked width is 33 inches, and the standard sheet lengths are 8, 10, and 12 feet. The metal finish can be smooth or stucco embossed. There are 2 different corrugation patterns available as shown here, what we call a 1 1/4 by 1/4 inch and 2 1/2 by 5/8 inch. Deep corrugated sheet is used on vertical vessels larger than 8 feet in diameter and other large tanks and equipment. It should never be used on horizontal vessels, as the troughs of the jacketing will collect water on a horizontal vessel, which can lead to corrosion and flow of the water through the jacketing joints into the insulation system. The next product line is our box rib sheets. These are our standard metal jacketing, cut to length and with a square wave pattern pressed into it. These are available in primarily aluminum and specifically alclad alloy aluminum, which offers very good corrosion resistance. Type 3 or 4 stainless is also available, but rarely ordered. The exterior surface is unpainted, so it has the natural emittance of the metal alloy used. The typical stocked width is 27 1/2 or 38 1/2 inches, and the standard sheet lengths are 8, 10, and 12 feet. The metal finish is typically stucco embossed, and the rib pattern, as shown here, is a 4-inch pitch with a 1-inch depth. The ribs in our box rib sheets provide added structural support to the jacketing. Box rib sheet is used on power plant breachings, large vertical vessels, and other large equipment. Like the deep corrugated, it should never be used on horizontal vessels or equipment for the same reason. The troughs can collect water. The last product line of JM metal jacketing that I will discuss is 2-piece metal elbows. These are an alternative to miter or gore metal elbows. JM offers 2-piece metal elbows in aluminum and type 316 stainless steel. We offer these in multiple sizes and shapes to fit various pipe sizes and insulation thicknesses. We have 2-piece metal elbows for both 45 and 90 degrees and for both short and long radius pipe elbows. We also have a line of elbows called multi-fit, which are designed so that each elbow can fit multiple sizes of pipe and insulation thickness. 2-piece metal jacketing elbows offer many advantages over miter or gore elbows. They offer much faster installation and can be installed by less skilled labor, both of which provide significant cost savings. They can shorten a project timeline or duration, and everyone knows how important this usually is for the facility owner. 2-piece elbows have fewer joints and much shorter total joint length, which reduces the opportunity for water to enter the insulation system through the joints in the elbows. 2-piece elbows provide what many believe is a superior aesthetic appearance. You can see some examples of this in the 2 pictures on the right. The top picture is a 2-piece elbow installed. The bottom picture is a gore or mitered elbow. Lastly, mitered elbows have a tendency to gap at the joints, as seen in the left picture, whereas 2-piece elbows do not have this problem. The 2-piece elbows, as you can see in the top right picture, have a very clean, finished appearance. It is vital that the proper 2-piece elbows be specified for a given situation. Consult with JM for more help when selecting the proper 2-piece elbow types and sizes for your particular application. Within the JM line of 2-piece elbows, our standard aluminum elbows are called LJAX Plus. These are 1100 alloy aluminum 2-piece elbows that are lined with polyfilm moisture barrier. JM is the only jacketing company that offers polyfilm lined metal elbows. These provide the added assurance of having the superior polyfilm moisture barrier to reduce the likelihood of jacketing corrosion on the interior surface of your elbows. The elbows from other jacketing companies only have a painted moisture barrier, which does not offer the superior corrosion protection provided by polyfilm. The polyfill in the LJAX Plus matches the performance of the adjacent jacketing on the straight pipe, which should also have polyfill moisture barrier. JM's LJAX Plus are compliant with the relevant ASTM standards and are made to fit on pipe elbows from 1/2 to 12-inch nominal pipe size. They are also designed to have increased spacing between the ribs and fingers for easier installation of banding in cold applications. That's the end of this portion of the webinar. I'll turn it over to Kim now, who will offer some closing comments, and then we'll address some questions.
All right. Thank you so much, both Jim and Scott. A lot of good information there. I wanted to talk to you a little bit today about additional resources that we have. And the first one I'm going to talk to you about is the source. And Jim, if you want to go ahead and make me the presenter, we can move forward.
There we go. Thank you. Gotcha.
All right, excellent. So the additional resources, the one I wanted to talk to you about is the source. This is our online educational resource repository. So today's webinar and all our webinars are hosted on the source, as are our ebooks, our latest blogs, relevant documentation, product comparisons, and then a tool resource library. So if you're looking for the NEMA 3E Plus tool to help you establish your insulation thickness on your hot systems, if you are looking for, I know Scott showed a slide earlier that had a product comparison, all of this information there is going to be in our tools section. You can access the source directly from the JM Industrial homepage, and that is, you'll see there are two yellow boxes circled. There's one in this left menu here, and then there's one on the right menu. Either one of those will take you directly to the source. And then finally, for everybody who attended today, we do have a certificate of completion that will go out to your inbox. That should be delivered sometime next week. And you can use this, assuming it is accepted by your accrediting body, you can use this for professional development hours. So with that, we did have quite a few questions submitted, and we're going to go ahead and launch right into this. Scott and Jim, are you guys both ready?
Yeah, absolutely.
Sure.
Excellent. So Scott, the first question is for you, and that is, I am particularly interested in insulation materials that can operate at 900 degrees Celsius.
Okay, 900 Celsius is going to be somewhere up around 1650 F, if I'm not mistaken. As you recall from our presentation, all of our products are rated for a maximum of 1200, except for our Super Cal Temp 1700, which is rated for 1700 degrees Fahrenheit. So if you have an application that can use a block or board formatted product, that would be an option. If you need something in a blanket format, you might then need to consider a ceramic fiber blanket of some type, which unfortunately is not a product that Johns Manville manufactures.
My fault, I was not unmuted. Let me ask the next question. The next question is, has your high temp line been used in any space or mil spec applications? We do have products that have been used in space and mil spec applications, so you can definitely follow up with us afterwards if you'd like more information on that. Yes. All right, thank you, Scott. The next question is, I would like to know what your highest temperature rated fiberglass is and how high of a temperature. I can go ahead and address that. We typically don't include fiberglass in our industrial portfolio because it doesn't go as high as our other industrial products. So our highest rated fiberglass is called a high temperature blanket, or HTB 26 blanket, and it is rated to 1000 degrees. The majority of our fiberglass materials that are used in higher temperatures are rated to 850 degrees. In industrial applications, however, if you're looking for a fibrous, lightweight insulation, we would definitely recommend mineral wool over fiberglass in most industrial applications. So, Scott, the next question is also for you, and that is, does calcium silicate keep its water-resistant properties if it's cut?
Very good question. The water-resistant feature of calcium silicate is actually part of the chemistry of the material while it is being manufactured. However, it does have a tendency during the molding and curing process for that chemistry to start to migrate a little bit away from the center of the material out to the outer surfaces. So if you do cut a piece of material, you could have some very, very small areas along the cut face toward the center of the product that might not be water resistant, but the balance of the material would obviously continue to be water resistant and therefore continue to provide the protection that you'd be looking for.
All right, thank you. Scott, the next question is also for you, and that is, when placing two sections of calcium silicate together, butt end to butt end, what size gap is acceptable between the two sections of insulation, assuming you're applying this to a high pressure steam line?
For any type of high temperature insulation system, we don't recommend accepting any type of gap in the material, whether it's on a circumferential or a longitudinal seam. If you do have any gapping at all, we would definitely recommend filling it with one of our accessory products so that you don't have thermal leakage points in the insulation system.
Excellent, Scott. Thank you. The next question is also for you, and that is, as the industry is looking for enhanced performance levels from insulation materials, what is the route taken in these new developments? Are they based on silica aerogel or microporous routes?
Another great question, but the answer would actually depend on what you mean by enhanced performance. Enhanced performance can be in a lot of different areas. If you're talking about thermal conductivity or thermal performance, then that would be the characteristic of the material you'd have to look at, and that is an area where thin blanket applications can offer better performance than some of the other products. If you are concerned primarily about corrosion under insulation, then you would definitely need to look at the performance, as we talked about at the beginning of the presentation, looking at the CUI performance of the material, and in that regard, you might want to look at a product like our calcium silicate or perlite that has the XOX corrosion inhibiting package in it. If one of your priorities is water resistance, then you would need to look at that. If acoustic performance is important, then you'd have to look at that. So there can be a lot of different things that can be defined as enhanced performance, so you really need to look at those critical characteristics and make sure you're analyzing the products accordingly.
Excellent. Thank you, Scott. The next question is about CUI, and I'm going to also give this one to Scott as well. You're in the hot seat today. So is there a chemical component in mineral wool that causes the cracking not related to residual stress, specifically related to carbon steel material?
I don't know that it's as much an issue of something inherent in the chemistry of the mineral wool material itself as it is just the fact that with your mineral wool systems and historically mineral wool not being water resistant and being a completely open cell or fibrous material, it would have a higher tendency for water to get into the system and bring corrosive compounds with it, and therefore create an environment where you might see a higher tendency for corrosion to occur in a system that is insulated with mineral wool than you might with other products.
And I'd like to add to that, anybody who's looking for more information on the chemical components and of insulation products and how they interact with, I believe, stainless steel coupons. I'm not so sure if it's carbon steel or stainless steel. We actually have an ebook on this that you can access on the source, where we specifically measured the interaction between the material, the insulation material, and the surface of the metal coupon, and the chemistry of the insulation material and the impact it had on that coupon, specifically the byproducts that it created. So I would definitely recommend anybody download that. All right. Scott, the next question is also for you, and that is, how UV stable is Thermo 1200?
That's a great question. We would not recommend leaving any industrial insulation product exposed to ongoing exposure to UV. You always want to try and jacket the insulation system as promptly as you can after the material is installed. It will not suffer any degradation during a typical installation. And to be perfectly honest, I'm not sure about any potential UV degradation that might result from long-term exposure, because again, that's not something that the material is intended to see.
All right. Thank you, Scott. I do realize we're coming up to the end of the hour. We have a number of questions. We will answer questions up till 15 minutes past the hour. Anything we don't get to today, we will address, we'll reach out to you privately to make sure you get your questions answered. I did want to remind everyone that if you have to drop off early, there is a survey that we would love to have your feedback, so certainly look for that as well. So the next question that we have, Scott, is for you, and that is, will the water-resistant calcium silicate not fall apart when it comes in contact with water? Will it lose its compressive strength?
Well, even the non-water resistant product wouldn't fall apart when it's exposed to water, because we don't use a water-based adhesive, but the water-resistant, water-repellent mineral wool will have a tendency to absorb less water much more slowly over time. When exposed to water, though, it is not going to just fall apart. Did I get the whole question on that, or was there a second part?
No, I think you got it just fine.
Okay.
There's also a video of this online if you would like to see how the water-resistant Thermo 1200 reacts to water exposure. You can visit that from our Thermo 1200 page. The next question is also for you, Scott, and that is, does the hydrophobic treatment for insulin also burn off at high temperatures?
Yes, it does. It is an organic part of the chemistry of the product, and that hydrophobic feature is going to oxidize and burn off when you get up around and above 600 degrees Fahrenheit.
All right, thank you. The next question is, what is the purpose for the adhesive in the V-grooved mineral wool?
It's primarily a benefit for the installation contractors. If it's an application that is basically going to be in a two-piece format, it allows you to pre-curl it and have it in a two-piece or a quad or even a semi one-piece that's hinged across from the opening. So it allows you to pre-curl the material, have it in a pipe format before you put it on. So it just makes it a little bit easier for the contractor to put it on.
Excellent, thank you. Scott, the next question is also for you, and that is, do you have any products for higher temperatures, say 2,300 to 2,500 degrees Fahrenheit?
For that temperature range, you would definitely have to look at materials like a refractory ceramic fiber or possibly a very high temperature ceramic fiber blanket. We do not have anything rated for anything higher than about 1,700 degrees Fahrenheit, which is our Super CalTemp 1700 product.
All right, thank you. All right, Scott, you can take a quick break. Jim, this next question is for you, and that is, what is the 1/2 inch safety hem used for?
It's designed to help prevent cut injuries from installers or people handling the jacketing. For aluminum, it's not so bad, but the edges of cut stainless steel jacketing are near razor sharp. So some people like to have a 1/2 inch fold on one edge, so that's the edge that on the jacketing will be ultimately exposed, or the edge that will be exposed. And by folding that under 1/2 inch, you eliminate the sharp edge on that particular edge.
All right, thank you. This is a joint question for you both, next one. And so, Scott, if you could start, and then Jim, if you could follow up, that would be great. And that is, what solutions for mineral fiber and metal cladding come off the shelf for roll-grooved connections, also Victaulic connections?
I'm not sure of as far as the mineral wool itself is concerned, I'm not sure of anything off the shelf. You would have to look at sizing your fittings accordingly to accommodate the topography that you would see in that type of a fitting. And typically you'd have to stuff any gaps with a loose fill material, because you don't want to create air gap cavities or anything within the system. So I'm not aware of anything off the shelf that we would have prefabricated to accommodate that.
from the jacketing standpoint, it all depends on how the insulation is handled. If the insulation has an outer surface that is a complex shape, various humps and ridges and changes of diameter as a result of going over the Victaulic type fittings, then you're going to have to the contractor is almost certainly going to have to custom manufacture the metal jacketing to fit over it. On the other hand, if the insulation is cut out by either a contractor or a fabricator to fit on the special type of groove fittings like Victaulics, and hence the outer surface of the insulation is smooth, then the appropriate sized the appropriate sized two-piece elbow can be used on top of that.
All right, thank you. The next question we have is for you, Scott, and that is, how does Insulin HT perform on stainless steel?
It should perform extremely well, as you saw from some of the CUI data, though that particular data set was related to performance on carbon steel. But because of the chemical nature of Insulin, it should perform very well in a stainless steel application as well.
All right, thank you. The next question we have is, does JM have any experience with seismic qualification of insulation and stainless steel jacketing systems for nuclear applications?
Sorry, I was still thinking about the prior question. Could you repeat that one, Kim?
Yes, absolutely. Does JM have any experience with seismic qualification of insulation and jacketing systems, stainless steel jacketing systems, for nuclear applications?
I'm not aware of anything specific that we have for that. I know our products do get used in nuclear applications, but I'm not aware of any specific seismic testing that's been done. If you want to reach out to us separately on that, that's definitely something we can look into further for you.
All right, we will take a note to follow up. From the standpoint of the jacketing, I don't think there would be much seismic impact on it. It's metal jacketing. I don't think the seismic strength or support of the pipe is going to be a key issue. I have been asked about seismic restraint, not for nuclear applications, but for cold applications. And in the cold insulation arena, seismic issues are dealt with a little differently than the normal support calculations. Normally, someone will come to us with questions about what strength of insulation is needed at a support location. And we can do calculations based on the pipe size, pipe schedules, span between supports, and other factors, and come up with the strength needed. For seismic issues, again, not nuclear rated, but for seismic issues, the inquirers have come to me in the past and said, we have done our calculations on what amount of force a certain kind of seismic resistance requires from the insulation. And maybe that's a force of 800 pounds in a particular loading point, a particular support location. If we have that kind of information, we could do calculations to tell you if our insulations, both hot or cold, would be sufficient to provide the necessary support. But it would strictly be a support number, not something specific to seismic or nuclear.
All right, thank you, Jim.
Yeah, Kim, I'd like to just jump in for a sec before you go to the next question. Back up to the question about Insulin and stainless steel. I would like to add to my previous answer that we do have all of the test results related to corrosion with austenitic stainless steel as they relate to the ASTM standards of C795, C871, and C692, demonstrating that Insulin does pass all of the requirements for that type of an application. So we do have that additional data as well.
Excellent. The next question we have is a joint question as well. So Scott, we'll start with you. Jim, if you could also follow up. And that is, are there differences in how CUI is addressed when a piping system is cooler than 212 Fahrenheit versus hotter than 212 Fahrenheit?
From an insulation perspective, there's usually two areas of concern when you're looking at process or operating temperature and corrosion under insulation. You have the applications that run within what is considered to be the corrosion zone, and so that would be a process that operates continuously in that range from about 50 degrees to 300 or 350 degrees Fahrenheit, and those are considered to be high-risk applications. Some folks seem to believe that processes that run above that range are at less risk because they are operating in an area where you won't have liquid water. However, I'm not aware of any processes that operate at those temperatures 365 days a year forever. So there are often conditions where either it's a cyclic system, so it operates in and out of the corrosion zone, or something that goes down for routine maintenance on some regular frequency or schedule, and therefore is going to be operating in and out of the corrosion zone as well. And those cyclic systems can actually be at a higher risk of corrosion than ones that operate within the corrosion temperature zone all the time. So to try and answer the question, we would treat the systems the same and assume that they are all going to be at pretty significant risk of corrosion, and make sure that you put together a good overall corrosion strategy, including picking an insulation material that is going to help minimize the risk for corrosion to occur.
I would add that I think Scott's answer is primarily focused at carbon steel. For stainless steel, the lower temperature limit for stress corrosion cracking of austenitic stainless steel is typically around 140 degrees F. So Scott's answer would be completely correct, with the one exception that instead of having a lower temperature, having the corrosion zone be lower, it would be between 140 F and whatever upper temperature number you want to use. I've heard 250, 300, 350 at different times from different people. So if you have much less of a concern with stainless steel operating in cyclical nature, because once it gets below 140, the chemical reaction of stress corrosion cracking is slowed to insignificance.
All right, thank you. We have time for about one more question, and so Jim, I'm going to go ahead and give this one to you, and that is the emittance value for stainless steel jacketing another word for emissivity for infrared purposes?
I don't know what infrared quite means in that question. I'll be honest, I hear the words emittance and emissivity used interchangeably in the industry. I'm sure some PhD physicist can tell you the difference between them, but for our purposes, emittance and emissivity can be considered synonymous. Stainless steel has an emittance or emissivity of about 0.3, and that is for all wavelengths of radiation, not just UV. That's its total across the board emittance for a wide range of radiation wavelengths. That number is used primarily for purposes of radiative heat transfer, which has a minimal influence on overall heat transfer rate, but a very strong influence on jacket or surface insulation system temperature for those situations such as condensation control and personal protection, where the surface temperature of the insulation system is of paramount importance. I'm not positive that answers the question, but I think so. I can add a tiny bit to that, Jim. I suspect that the questioner is inquiring about infrared thermography. And in that regard, what you're going to find is that the low emittance metal jacketing does not lend itself well to infrared thermography because it is highly reflective of infrared energy.
So if you try to do infrared thermography with metal jacketing, you're going to get a nice reading of the temperature of the metal, but not a good indication of what's going on beneath the metal. In those arenas, non-metallic jacketing systems like an elastomeric or GRP type jacketing system, which have a very high emissivity, will lend themselves better to infrared thermography and being able to see what is going on within the insulation material itself. One exception to that could be a painted metal, which obviously would have a high emittance, as well.
All right. Thank you both. That wraps up our presentation today. We will send a recording, including the Q&A session, to everybody. If we didn't get to your question today, we will reach out to you privately to have a discussion. So you can look for our personal email in your inbox. And then additionally, we will be sending the recording of the webinar and your certificate of completion into your emails probably sometime in the next week or so. So thank you all very much for your time today, and have a great rest of your week.
Thank you, Kim, and thank you, everybody, for joining us.